Hello and welcome to our basic introduction to trigonometry. Now the word trigonometry comes from two Greek words, trigonon meaning triangle and metron meaning to measure. So the word actually means triangle measurement. Now if we look at a basic right-angled triangle, we might be familiar with this equation, c squared equals a squared plus b squared. So that's Pythagoras. And if we have the measurement of two sides, we can work out the third side. But what happens if we only have one side, but we also have this angle here, which we'll call theta? Well, then we'll have to use the trigonometric equations. The tan of theta is opposite over adjacent, the sine of theta is opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. But what do these mean? Well, in a right-angled triangle, the longest side is the hypotenuse. The side that is next to the angle is called the adjacent side, and the side opposite the angle is called the opposite side. But how can we memorize these equations easily? Well, I use this sentence: two old angels sitting on high, chatting about heaven. There are lots of other people who use Sokotoa, or if you wanted, you could use something else that you make up, whatever easiest for you. So now let's put it into practice and see how it works. So here we have a right-angled triangle. We know the angle is 30 degrees and we know the hypotenuse is 12 centimetres. Now if we want to find the length of this side A, which equation do we use? Well, we know the length of the hypotenuse, and the length of the side we want to find is the adjacent side. So we need to find an equation that has the adjacent and the hypotenuse in it. So if we look up here, we can see that we need this equation with the cosine of theta. Well, as you can see, the cosine of theta, which in this case is 30, is equal to the adjacent side, which is A, divided by the hypotenuse, which is 12. So if you use your calculator or look it up in tables, whichever method you're using to find cosine of 30, you'll find it's 0.866. So by rearranging the equation, we can find out that A is equal to 0.866 times 12, which is equal to 10.4 centimetres. Now, if we had the hypotenuse, but we wanted to work out the length of this side, B, we'd need to find an equation that had the hypotenuse and the opposite side in it. So if you look above, you can see that that would be sine of theta. Now, the sine of theta is equal to the opposite, which is B, over the hypotenuse, which is 12. Now, if you work out the sine of 30, you get 0.5. So by rearranging this equation, we get that B is equal to 0.5 times by 12, which is equal to 6 centimetres. And likewise, if we don't have the hypotenuse, we only have a measurement of one of the sides, for instance, the opposite side, and we want to find out the adjacent side, the equation we're going to use is the tan of theta. So if we know that the opposite side is 6 centimetres long, we have the tan of 30 equals 6, the opposite side, divided by A, the adjacent side. This means that A is equal to 6 divided by tan 30, and if we work out that the tan 30 is 0.577, that's 6 divided by 0.577, which is equal to 10.4 centimetres. Well, that's it for this video, but we'll go through lots of examples in following videos, so I hope to see you there.